All right, Algebra 2B. As we move on to our next unit, which is called polar coordinates, we will be graphing on a different set of axes other than your XY. We're going to be graphing on what's called the polar axes, and we'll get to that towards the end of today's notes. Before we get into some new stuff, I want to review some old Algebra 2 concepts we did in the fall before we took the Algebra 2 Regents exam. Okay, and the first one is converting back and forth between degrees and radians. Okay, you remember there's one way to measure an angle in degrees, and there's another way to measure an angle, which is called radians. All right, so for the first one here, it's saying take 120 degrees and convert that into radians. All right, instead of getting the old formula sheet out, I wrote the conversions right up here. All right, so we are given degrees and we want to go to radians. Again, given degrees and we want to go to radians. So what we're going to do is we're going to take 120 and multiply that by pi over 180. Okay, and what I'm looking for you guys to do is the following. Keep the pi in your answer. And now, instead of leaving it 120 over 180, reduce that sucker down. All right, and the way we can reduce it is you can go to your graphing calculator, put 120 over 180 in a fraction template. So 120 over 180, and the calculator will reduce it for you. 2 pi over 3. Okay, so that is what 120 degrees is in radians, 2 pi over 3. Okay, now we're going to go in reverse. Now I have 7 pi over 4 radians, and I want to turn it into degrees. So now again, I'm given, take a look, given radians, want to go to degrees. So what do I multiply by? 180 over pi. The conversions are right up there. The reason I do that, the pi's cancel each other out. And now I'm just doing 7 times 180 and then dividing that by 4. So 7 pi over 4 radians is the same as 315 degrees. Okay, next up, I got negative 2 pi over 3 radians. Again, I'm going from radians to degrees. So I want to multiply by 180 over pi. So I need to cross off the pi's, multiply negative 2 times 180 and divide that by 3. And that should end up being negative 120 degrees. Okay, so just a little review, going back and forth between radians and degrees. All right, we used to love this, and that is drawing an angle in standard position. Okay, first thing, with an angle in standard position, one side is always on the x-axis here, on the positive side of the x-axis. That's called my initial side. And then we have another side called the terminal side. The terminal side ends up in a quadrant. So let's go review one quickly here. You got 0, 90, 90, 180, 270, and back to 360. Okay, so an angle of 145 would end up being somewhere in the second quadrant, and you do want to be somewhere in the ballpark. Is it going to be closer to 180 or closer to 90? It's going to be closer to 180 degrees. So I make my arrow closer to 180. Now, the only other thing you need to tell me is the rotation arrow, which direction is it going? So there it's going always counterclockwise. Okay, so 145 degrees. Next up, I got negative 30 now. So I got my initial side. So let's take a look. Where's my terminal side going to be? Well, now, because it's negative, we go in a clockwise direction. So take a look up here. I got negative 90, negative 180, negative 270, and back to 360. Okay, so negative 30 would be in the fourth quadrant, closer to 0. So right here. And that's why you want your rotation arrow. It's so important. Going this way. Okay. And then you guys can try out right now 295. That's going to be in the fourth quadrant, closer to 270. So we want to make it closer to 270. And we want to make sure we got our rotation arrow going in a positive direction, counterclockwise. Okay, now we're up to radians. Okay, now we're going to radians now. So you got negative 5 pi over 6, and I want to graph that. Well, I just showed you guys what it is by degrees. So why don't we stay with degrees and take negative 5 pi over 6 and convert it into degrees, just like we did up and above at the beginning of the talk today. So I'm going to multiply it by 180 over pi. I know I'm going quick, but this is, we have done this before. Pi's cancel out. And this is the same as negative 150 degrees. So again, I make my initial side. Where's negative 150? Go back, look if we need to. Negative 150 looks like it should be in quadrant 3, closer to negative 180. So that's what we'll do right here. And make sure my rotation arrow is going clockwise. All right, same thing. Number 5, 13 pi over 8. 180 over pi. Pi's are gone. Now I'm doing 13 times 180 divided by 8. So you can do that right in your calculators. And that should end up being, we got a little decimal action here, 292.5 degrees. Okay, so let's go get your initial side set up. Let's see, 292, that should be in quadrant 4, closer to 270. There it is. And let's get our rotation arrow going in a counterclockwise direction. Okay, so drawing your angles in standard position. All right, so hopefully something's coming back now from when we did this in the fall. All right, next up, coterminal angles. All right, you need to find an angle that's got a positive measure and an angle that's got a negative measure that's coterminal. So at the end of this problem, at the end of these problems, I need a positive angle and a negative angle. But first, we got to review what coterminal meant. So real quickly, if I have an angle of 50 degrees, we all know that's going to be in quadrant 1, closer to 90. Okay? Going this direction. Remember, what coterminal meant was, can you come up with another degree measure that gives me this same diagram? Okay? With a terminal side in the first quadrant that's pretty close to 90. All right? Can you give me another degree measure other than 50? Positive and negative, other than 50, that's going to result in the same angle measure. Well, the easy way we did this in the fall was, hey, let's go all the way around. And when I go all the way around, how many degrees are you going? You're going 360. So I can take the 50, go all the way around, add 360, and an angle of 410 degrees will also have this same looking diagram with a terminal side in the first quadrant. Now, what do you think I would have to do to get a negative angle? Well, go in the other direction and subtract 360. 50 minus 360, so now that'll be an angle of negative 310. Okay? So I can add and subtract 360 until I get a positive or a negative angle. So let's do that for 580 right now. So I can take 580, add 360 to it if you want. So I'm going to do a little cheat here. 580 plus 360, 940. Okay. Now, when I subtract 360, you'll notice I end up with 220. Now, that could have also been a positive answer. There's multiple answers here. That could have also been one of my positives, but I still don't have a negative degree measure. So I'm going to keep subtracting 360 until I do have a negative degree. So now I'm at negative 140. Okay. All right, so there's degrees. Now we get to radians. Okay, now we get to radians. All right, notice number 3 and 4 are in radians, which means, I hate to break this to you, but your final answer, your positive and negative angles have to be in radians as well. All right. And you guys are big boys and big girls, so I'm not going to take the easy way out here. All right. I'm not going to convert this to degrees, do what I did up here in numbers 1 and 2, and then reconvert them back into radians again. Okay. It's too much work, not too much work, but just a lot of writing going on. Okay. So I have 5 pi over 6. All right. So I take 5 pi over 6. Now, up above, we would add 360 and subtract it. So what we're going to do is, instead of adding and subtracting 360, we're going to add and subtract what 360 is in radians. So up above here, you may want to make a note, 360 degrees is the same as 2 pi radians. Okay, 2 pi. So what I'm going to do here to 5 pi over 6, I'm going to add 2 pi. And you guys are seniors now, ready to go to a college or a university, and I think you should be able to handle this now. All right, so when I add these together here, I'm going to need a common denominator. All right, because this is over 1, so my common denominator looks like it's going to be 6. So it's going to be 5 pi will stay 5 pi. What do you multiply 1 by to get 6? You got to multiply it by 6. So this is going to be plus 12 pi. And then just finish it off. There you go. 17 pi over 6. A lot quicker than trying to convert. All right, so 17 pi over 6. All right, let's do it now. But now we're going to subtract 2 pi. So here we go. 5 pi over 6 minus 2 pi. Hey, you already did the tough work, right? You already know what's going to happen here. You got a denominator of 6. 5 pi stays 5 pi, but now you're going to subtract 12 pi over 6 and end up with negative 7 pi over 6. Not too bad. Nice and quick, right? So we don't have to convert back and forth. All right, let's do it again. 1 doesn't make us great, right? So now I have negative 7 pi over 3. Let's add 2 pi to it. So my common denominator now will be 3. Negative 7 pi over 3. Now what do I have to multiply 1 by? I got to multiply it by 3. So now that 2 pi is going to change into 6 pi. Okay, 6 pi. So now it should end up being negative 1 pi over 3. There's my negative answer. Right? There's a negative answer. How do I get a positive answer now? Keep going. Negative pi over 3. Let's add 2 pi to it again. So now that's going to be, again, 3 is my common denominator. And now I have negative pi here. Again, multiply it by 3. You get 6 pi here. So you're going to end up with 5 pi over 3. So there you go. So add or subtract 2 pi when you're dealing with radians. All right. So hopefully we're good so far. We're getting into the home stretch now. You guys, your entire mathematical career have been graphing on an X, Y axis. I would like to introduce you now to a new type of grid called the polar grid. All right. This is what it looks like right here. All right. The polar grid. Now, within the polar grid, you should see your XY grid. All right, you should see it. Take a look, guys. Look at it right there. It still exists. I just got a lot more lines going around now. All right, so it still exists. All right, so how to label a polar graph first. Let me do it in degrees first, and then we'll flip over to radians, okay? So first thing, I like to get my I'd like to get my XY grid done. All right. So again, you guys know I start at 0, 90, 180, 270. All right. And if I had you guys count all these up, all right, so if you see from 0 to 90, I have 1, 2, 3, 4, 5, 6 evenly spaced out. All right, again, 1, 2, 3, 4, 5, 6, evenly spaced out for 90 degrees. So that tells me, okay, I'm going to do 90 divided by 6. Every time I go is 15 degrees. Okay, every time I label a little mark, it's 15 degrees. So 15, 30, 45, 60, 75, and now I'm at 90. Okay. All right. So just putting that out there right there. Okay. What I'm going to do right now is pause the video, and I want you guys to continue on all the way around in degrees for me. Okay. In degrees. Finish that for me. Okay. So there is your, I tried to write as neat as possible. Sorry, but there should be all your degree measures around the polar grid. And what the polar grid is doing, hopefully you can see, is it's a little bit more exact than our little drawings we did here, 1 through 5. Okay, it gives a little bit more preciseness and detail to when we start graphing these angles. Okay, so let's go over to radians now. All right, radians. We still have 0. Okay, now remember, in the degrees, they went by 15 degrees. So what we would have to do is say, all right, what's 15 degrees in radians? And that's what it would go by. And if I had you, I'll do the conversion for you. 15 degrees in radians is pi over 12. Okay, pi over 12. So every time you go a marking, you're going to go pi over 12. Now, the easiest way to do this is just count. So this right now, I just put down 1 pi over 12. Now it's going to be 2 pi over 12. 3 pi over 12. Now, and if you are interested in reducing, go right ahead. That's fine. I'm just going to keep them at a 12. 4 pi over 12. If you want to reduce that to pi over 3, that's fine. 5 pi over 12. And now we have 6 pi over 12. I am going to reduce that down to pi over 2. So we're on to 6, and it just keeps going. 7 pi over 12. 8 pi, 9 pi, etc. So go ahead, finish the radians up going by pi over 12s. Pause your video. Okay, mine would have just been an absolute mess if I kept labeling it around, but as you guys can start to see, you just count by pi over 12s. 1, 2, 3, 4, 5, all the way around. If you want to reduce, go ahead and reduce. All right, but I like it at a 12. Okay, and the last thing we got to do is now let's graph this a little easier now. Okay, let's start graphing these. So label on your polar grid now the angle of 105. Okay, so same thing's going to apply as we did at the beginning of this lesson. I always just like to see where my XY axes would be. All right, the initial side is still on the x-axis at 0. Now you just got to remember where 105 was. Well, remember 90 was on top, right? And they go by 15, so 90 plus 15, that would have given me 105 right here. And now this gives me a little bit more exactness to where 105 degrees would be. Okay, and yes, just like before, I need my rotation arrow to show me what direction we're going in. Okay, so next up, negative 300 degrees. Okay, here we go. And again, is it necessary for you guys to draw in that XY axis like I'm doing right now? Nope, not at all. I just like having it in there as a little reference point for me. Okay, so negative 300 means I'm going in a clockwise direction. Okay, so again, if that was 360, instead of going, and that was 0, instead of going up negative 15, negative 30, like that, it's going to take me a while to get to negative 300. I like to work backwards. All right, I like to work backwards. So if that was negative 360, this is negative 345. This is negative 330, negative 315. There it is, negative 300. It gets me there a little bit quicker. Okay, so I'll take my initial side, go up to negative 300. There it is. And again, rotation arrow going clockwise because it's negative. All right, let's keep going here. 240. All right, I'll let you guys do. You can go ahead of me if you want. 240. Actually, you know what? I'm going to pause the video. You try 240. Okay, so there's 240 degrees. All right, hopefully we both had it in the same position. All right, let's go radians now. All right, so first one here, I got 10 pi over 12 radians. I am not going to allow you to convert it into degrees and do it that way. All right, it takes too long. Remember what we said before. Each marking goes pi over 12, and this is what it's out of right now. It's already out of pi over 12. So all I need to do is go 10. All right, 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. All right, easiest way to do it right there. It goes by pi over 12, so if it's already at a 12, perfect. And make sure you got your arrow. There we go, we're in business, 10 pi over 12. All right, what if it's not at a 12 and I can't just count? Well, guess what, kids? You're gonna make it at a 12. All right, look at this next one, negative 3 pi over 2. The denominator is 2, but you want to make it out of 12, so you can go by each marking. So you say to yourself, what are you going to multiply that 2 by to get 12? You're going to multiply top and bottom by 6. So now that becomes negative 18 pi over 12. So now you're going to find 18. So now we're going to go 18, but remember, you're going to go in a clockwise direction. All right. And if you remember, going all the way around is 12. All right. So going from the beginning to the opposite side is always 12. So I can go that. I can go 13, 14, 15, 16, 17, boom, 18. There it is right there. Let's graph it. And make sure I got my arrow going the correct way. Okay. Last one, 7 pi over 4. Multiply top and bottom. How do you make that into a 12? Multiply top and bottom by 3. Okay, multiplying top and bottom by 3. So really, I'm going to go, let's see, 21 pi over 12. So I'm going to go 21 spots. Now let's learn a couple tricks here and there. Remember, when you go all the way around, that's 24 spots, 6 apiece, right? So wouldn't it make sense to go backwards now? So if I'm at 24 here, 23, 22, boom, 21 right there. I can just draw it out. And there it is. Making sure we go in the correct direction. Okay. Guys, day 2 graded assignment is nothing different than what we just did, except I just changed the problems. The numbers, the degrees, and radians. That's all I did was change them. All right, so please use day number 1 in this video to help you out. All right, talk to you guys later.